Our last section, or our last part of this section, is all about mental math and estimation. So when we talk about mental math, what we're talking about is finding an answer to a computation without using computational aids, so doing it in your head. When we talk about computational estimate, we're talking about getting an approximate answer. Okay, so let's look at a bunch of tricks for doing these. So mental math, one thing we could do is add from the left. We saw this with our partial sums or our left to right addition, right? So add the 10, 70 plus 20 is 90, then add the 1, 6 plus 5 is 11, and then add those two together. Now you're doing this mentally in your head, right? But we're writing it out so that you can see what the process is. So 90 plus 11, we get 101. Breaking up and bridging. This is sort of borrowing from 1 to, breaking up the 25. So I'm going to pull it into 20 and 5 and then add each of those separately. So 76 plus 20 is not so bad to do in your head. That's 96. And now we need to add the 5 to that, and that's going to get me up to 101. I could trade off. This is where I want to do the compensation here. So 76, if I add 4 to it, that gets me up to 80. And so I'm going to compensate by subtracting 4 from 25. And so that gives me 21. And now I can add 80 plus 21 in my head. A little bit easier to get 101. We can use compatible numbers. So compatible numbers are numbers whose sums are easy to calculate mentally. Things that are multiples of 10 are easy to calculate. Things that build to, say, 100 are easier to calculate. So if I'm looking at this long list of numbers that I want to add, I might recognize that if I add the 130 plus 70, that gets me 200. Those are compatible numbers, right? And the 50 plus 50 are compatible numbers. They give me a nice sum of 100. And so now I have 300, and I just need to add my 20 to get 320. I can make compatible numbers if I don't already have compatible numbers. So multiples of 5 are usually nice for compatibility. So if I'm adding 76 plus 25, I might say, well, 76 is awfully close to 75, which is compatible with 25. Kids are dealing with money a lot, right? So 75 plus 25 is 100, and now I need to add one more to get my answer for 76 plus 25 to get 101. All right, let's look at estimation. So there are a couple tools we're going to look at for estimation. The first one is this front end with adjustment. So I'm going to look at the front end digits. Here I have 4, 5, and 2. I'm going to add those together to get 11. And so adding in place value here, that was in the hundreds, so that's 1100. And now I'm going to adjust the other numbers. So 22 and 31 is about 50. 74 is about 70. It rounds down to 70. So if I add 50 and 70, I get about 120. And now I'm going to add that to my 1100 to get an adjusted estimate of 1220. I can group to nice numbers, so I want to look at numbers that are almost compatible. Okay, so if I'm adding this long list of numbers here on your screen, I might notice that 39 is close to 40, 64 is close to 60, so those are about 100 if I add those two numbers together. And looking at the other three numbers, 23 and 32, that's about the same as 20 plus 30, which is 50. 49 is pretty close to 50, so those three numbers together give me about 100. So the total here should be about 200, right? 100 plus 100. Clustering is what we're going to use when we have a group of numbers that we're adding that are all sort of clustered around a common value. So here I'm adding 5 numbers that are all really close to 5,000, right? And so the total here should be close to 5 times 5,000 or 25,000. Of course, we can round, so 7,262 minus 3,806 is close to 7,000 minus 4,000. So why might we want kids to be good at estimating? Well, that gives them a tool to help them decide if their answer is reasonable, right? We want them to be able to look at an answer and say, yes, this is a reasonable answer, or no, I must have done something wrong. Because if I look at this really quickly, I can see that the answer should be close to something that's very different.